Today's lesson is on simplifying exponents. Write an equivalent expression for 5 squared times 5 to the 4th. 5 to the squared means I have 5 times 5. And I'm multiplying that by 5 to the 4th power, which means I have 5 times 5 times 5 times 5. If I count up how many 5s I have together, all together now, I have 1, 2, 3, 4, 5, 6. So I end up with 5 to the 6th power. An easier way to do this is to recognize that when you have the same base, the 5s are the same, you can just add the exponents. So this becomes 5 to the 2 plus 4. And 2 plus 4 gives me 6. So I have 5 to the 6th power. Second question. Write an equivalent expression for 5 squared raised to the 4th power. So if I have 5 squared raised to the 4th power, that means that I have 5 squared times 5 squared times 5 squared times 5 squared 4 times, because it's being raised to the 4th power. 5 squared is 5 times 5. 5 squared again is 5 times 5. 5 squared again is 5 times 5. 5 squared again is 5 times 5. If I count how many 5s I have 1, 2, 3, 4, 5, 6, 7, 8. So this becomes 5 raised to the 8th power. An easier way to recognize this is if you have an exponent raised to another exponent, you can just multiply the exponents. So this becomes 5 to the 2 times 4. And 2 times 4 is 8. So I end up with 5 raised to the 8th power. Question 3. Write an equivalent expression for 5 to the 6th over 5 to the 2nd power. 5 to the 6th is having 5 times 5 times 5 times 5 times 5 times 5. That is all in the numerator. 5 to the 2nd, I have 5 times 5. I can cancel out from the numerator and the denominator what's the same thing. So I can cross out a 5 and a 5. I can cancel out another 5 and another 5. There's nothing left in the denominator for me to cancel out. So I have 1, 2, 3, 4. I have 5 raised to the 4th power. An easier way to look at this is when you have the same base, the 5 and the 5 for both of them, and they're being raised to an exponent, and they're being divided, you can subtract the exponent. So it's 5 to the 6 minus 2. And 6 minus 2 gives me 4. So I end up with 5 raised to the 4th power. The last question. Write an equivalent expression for 5 to the 6th power times 3 to the 6th power. This problem is a little different because my bases are not the same. But if you look at this, you're able to notice that I have the same exponent. Both of them are being raised to the 6th power. So when I have the same exponent, I can write the two bases together, 5 times 3, and I can raise that whole expression raised to the 6th power. I can simplify this. 5 times 3 gives me 15, so it becomes 15 raised to the 6th power.